What is going on, guys? Welcome back. In this video we'll be talking about the limits. Limits are a huge aspect of calculus and higher math, and it's going to be with you for the rest of your math career. From derivatives to integrals to even vector fields and differential equations. Limits exist everywhere now. And this video serves as an introduction of the intuition behind limits, but not the actual definition, just because that's a bit more advanced. And we'll do that in a later video. But so pretty much, so we're going to be looking at the function x squared minus x plus 2 for a for values equal or close but not exactly equal to 2. Okay, so we call that approaching. When they're close but not equal to, we call it approaching. Sorry about that, guys. Alright, so pretty much, yeah, so values close but not equal to 2. Exactly. So pretty much we are approaching 2. Okay, so looking at numbers where x is less than 2, or on the left side of 2, well, okay, so we plug in 1. Okay, so we plug in 1, we get 2. We plug in 1.5, we get 2.75. We plug in 1.8, we get 3.44. We get 1.9, 3.71, 1.95, 3.8525, 1.99, 3.901, 1.995, 3.985025, 1.99, you get 3.99701. Okay. So what's really going on here is, all right, well, so we chose numbers on, so we're choosing numbers arbitrarily close to 2. So this 1.9, this 1.995, 1.999, 1.995. And the closer we zone into 2, it gets closer to a value. So think of a limit as saying, okay, well, we want to zoom into values very close to 2, and we want, values close to a number we are approaching, and how does the function behave then? What number does it get close to? All right, and so we can do the same thing for the right side. Numbers numbers where x is greater than 2. All right, so starting at 3 because it's further away. So 3 goes to 8, 2.5 goes to 5.75, 2.2 is 4.46, 2.1 4.31, 2.05, 4.0301, 2.005, 4.015025, and 2.0001, 4.0030. Okay, so essentially it's the same aspect, but all right. So on the left side, it's increasing the value, but on the left side, it's decreasing the values because we're getting closer and closer to 2. Okay, and on the left side, it looks like it's getting closer to 4. Okay, if you look as we zoom in closer to values, it looks like it's getting closer to 4. So we can say the limit's 4 on this side. Look on this side. All right, as we zoom in values close to 2 as well on the right side, as it's decreasing, it looks like it's getting close to 4 as well. Okay, so the left hand limit is 4. The right hand limit is 4. We say the actual limit is going to 4 as we approach 2. Okay, so talk about it from a general perspective. All right. So before we actually talk about it in generally, all right. So we have limits. All right. So the common notation is the limit as f of x. The limit of f of x as x approaches a. So this lim is limits of our function as x, the arrow means approaching a. Our value we're approaching is equal to L, the limiting value. And this is two-sided limits, so we checked both the left and the right for this one. Okay. Now we do have one-sided limits as well. If we have the limit as x approaches a with a positive sign, that means from the right. So this is from the right. And this is the limit as x approaches a of f of x is equal to L, which is the left hand. All right, with the minus sign is left, from the left. So this is the left hand limit. All right, and both the left hand and the right hand limits need to equal to have for the actual limit to exist, the two-sided limit to exist. All right. So pretty much, all right, we could say, okay, well, let's make sense of this real quick. Okay, so we said so we're not really worried about what happens at A. In fact, for a limit to exist, we could either have a function that's either, so going to this graph, we could have a function that's defined at A, or there could be a hole at A. There could be a hole here as well. And the limit will still exist. The function won't exist. It won't be continuous, but it would the limit would exist here. So pretty much, if we take the left hand limit, so we take values getting closer and closer and closer to A, the left hand, and the closer and closer getting closer on the right side. Well, we say, okay, if both of these get close to this one value, then this value L, the functional value L, sorry about that, then the limit is L. So the limit as x approaches A of f of x is equal to L. That's all the limit says, pretty much, is we're zooming in close to a value, and we will be we zoom in close to a value, and what is the y? How does y affect the function? How does the function behave as we get close to a functional value, as the next value on the x-axis? I hope this helps out, guys, and we'll continue more of this next time. I'll see you guys later.